our problem, gaseous ethane reacts with oxygen gas to produce gaseous carbon dioxide and water. For the equation, you would need 2 ethane that would give you 4 carbon to create 4 carbon dioxide and 12 hydrogen to create 6 water, and to fully balance the equation you need 14 oxygen, so you put 7 in front of the O2.
So for part A of the problem, suppose the chemist mixes 13.8 grams of ethane and 45.8 grams of dioxide. Calculate the theoretical yield of water. So for part 1, we'll take the starting mass of ethane, which is 13.8 grams, and we will multiply by 1 mole over 30.08 grams of ethane. 30.08 grams of ethane would be the molar mass. And then once we do that, we would multiply it by the molar ratio, which is 6 waters per 2 ethane. Then multiply it by the molar mass of water, which is 18.02 grams over 1 mole, and that will get you 24.8 grams of water. And then for part 2, you would take the starting mass of dioxide, which is 45.8 grams, and then multiply it again by 1 mole over 32 grams of dioxide, which is the molar mass. Then again multiply it by the molar ratio, which is 6 water per 7 oxygen. Then multiply it by 18.02 grams of H2O over 1 mole, and that will get you 22.1 grams water. So after you've calculated your end results of grams of water, you want to look at which one is the smallest number, which will be your limiting factor. So once you get your limiting factor, which will be the 22.1 grams of water, that'll be your theoretical yield.
Suppose the reaction actually produces 14.2 grams of water. Calculate the percent yield of water. To find percent yield, you take the experimental yield divided by a theoretical yield times 100. So we have 14.2 grams of H2O divided by 22.1 grams of H2O. We got our theoretical yield from our last equation, and you multiply this by 100 and you should get 64% yield.
So for part C, the question is, what kind of reaction is this? So there are 5 types of reactions: combustion, synthesis, decomposition, single replacement, and double replacement. And if we look at our original equation, we end up with CO2. And if you look at combustion, that also ends up with CO2. So therefore, it would be combustion.